that small over big, smaller degree over a larger degree, makes there be an asymptote at just y equals 0, so just the x-axis. If you want to sketch that, it would be a horizontal asymptote right there. If the degree of the numerator equals the degree of the denominator, then your asymptote comes from the coefficient. So it's going to be some horizontal line, and this is what we had called same over same before. So your horizontal asymptote will be wherever the value of a over b puts you. Not going to be 0. And if the degree of the numerator is bigger than the degree of the denominator, then there is no horizontal asymptote. There is an asymptote, though. It's just a diagonal one. It's a linear, so it would almost be something like this. So if I were to sketch something like that, you know, some function that does that, and as it goes towards infinity, it's just approaching a diagonal line as opposed to a horizontal line. And we can find what that line is just by doing long division. If you do long division of your function, you will get the equation for the diagonal asymptote, which I don't know if we get into here, but that's kind of interesting. Alright, so find each of the following limits. So as x approaches infinity, we want the limit of this. Now, this is not written strictly as a polynomial divided by a polynomial, but we can make it written that way. So we can get a common denominator, give this an x squared and give this an x squared. So our function will be 5x squared minus 2 over x squared. So what category does this fall into? Small over big, big over small, or same over same? Same over same. So our horizontal asymptote should be where? Y equals 5. Because that's the coefficient of a 5 divided by a coefficient of a 1. Y equals 5. So as we approach infinity, this limit should be 5. And just for the sake of wrapping our head around that, here's that graph. And sure enough, as you go towards infinity, this is kind of balancing out at 5. Good? And the same is true as this goes towards negative infinity, which is worth noting. What category does this one fall into? So what would this limit be? Good? I'm just going to show it to you just so we can... Yep. So you have a horizontal asymptote of 2, and both as you're going towards positive infinity and as you're going towards negative infinity, it's going towards 2. What category does this one fall in? Small over big, so what would that limit be? 0. Go ahead and do the next 2. No. Even if it is a diagonal asymptote, all you have to decide is it going up towards positive infinity, or is it going to go to, if you had your, you kind of got to think about end behavior, if that was your graph there. I don't know how I'm going to do this one. Something that goes, and you can cross these asymptotes, but something that's going to run like there as you go towards infinity. Something like that, I don't know, I just made that up. But when you just want to think about end behavior on the one where it has a diagonal asymptote. Okay, so this one we thought was 0, right? And I just went ahead and graphed that for you just to show you and prove to you that that sure enough was the case. As x went towards infinity, we went towards 0. Bryce L., what did you think for the second example? He put 2/3. Does anybody disagree? Okay, here's this graph. Kind of tough to see, maybe unless we changed our window from 0 to 1, and then 2/3 would be up here somewhere, and that seems to, I'm going to even make this bigger, negative 50 to 50. Oops. Yeah, that seems to be 2/3 of the way up from 0 to 1. Good? Make sense? And Maggie, what do you think for the last one? Okay. So take a minute. I'll give everyone another minute to think about this one. So reminder, if there is no horizontal asymptote, the answer is just infinity or negative infinity. If, I'm going to write that. Oops, that was redundant. If no horizontal asymptote. So really, well, I don't want to say it, but Maggie, what did you get now? Positive infinity. You just have to plug in a number that's towards positive infinity and decide, are you going to get a positive? But once you already know the answer is one of these two, plug in a huge number, plug in 100, and just decide, are you going to get a positive or a negative? If you plug in 100, you're definitely going to get a positive over a positive, which is a positive. So your answer is positive infinity. Okay, here's that graph. Yes? And if they asked you what the limit was as x was approaching negative infinity for this same graph, obviously, again, it's still big over small, so there is no horizontal asymptote, so our answer has to be positive infinity or negative infinity. If you plugged in negative 100, your numerator is going to be negative divided by positive, which would be a negative infinity, and the graph we just saw back that up. Good? Okay? Now, just for the sake of doing it, because it is kind of cool and worth knowing, I said if we did long division with this, we would get the equation for the line. Now, because this wasn't in the plan, I don't know if this is going to be a nice long division or not. Yeah, because we're missing 0x squared, 0x. I'm going to throw those in there. Good call, Dan. So, this isn't going to be the best, but 3 times what will give me 2? 2/3. Good call, Dan. So 2/3 x, yes? Okay. So when I multiply that out, 2/3 x times this is going to give me, the 3's are going to cancel, it's going to give me 2x cubed plus 2/3 x, which I'll line up underneath the x term. So when I do my subtraction, this is going to cancel. 0x squared minus nothing is going to cancel. And 0x minus 2/3 x gives me negative 2/3 x. Bring down your positive 5 and repeat. But the game is over, right? because everything hereafter, this is just our remainder, because 3x squared times nothing gives us negative 2/3 x, right? So the rest of this is remainder stuff, and here's your asymptote, y equals 2/3 x. So watch what happens on this graph when I plot the equation 2/3 x right alongside of the function, and you can see it just go there. You can see that it's an asymptote, and the graph is pretty much tracing along it from there to infinity. It's not exactly on it, but it's essentially as close as you can possibly be without touching. Does that make sense? Yeah. When you do long division, when you divide them, you're going to get the oh, if you just take the first two terms. Not always, no. You actually have to do the long division. I'm like 90% sure. I haven't done a whole bunch of these in a while, but yeah, because sometimes it could be like a 2/3 x plus 3. Like it's not, like it just so happened that with this one, the way it panned out, the answer kind of ended. But if we had an x squared term, we would have to figure it out 2/3 x plus something else. And then your line would have been shifted up or down somehow. Okay? Alright, so on the back here, what's the limit as your sine graph approaches infinity? Does not exist. Very good, Alex, because that's oscillating back and forth, and it doesn't ever even out. This sine x over x graph that we haven't seen in a while. Okay? When you think about, and I'll show it to you and remind you what it looks like in a minute, but this is the one where we memorize the limit as x approaches 0 for. Here's a little final exam review. Right? This was 1. But now, and again, I'll show you what the graph of this looks like in a minute, but let's think for a second. What happens to the limit of the numerator as you approach infinity? Doesn't exist because it keeps bouncing back and forth between 1 and negative 1, 1 and negative 1, and negative 1. But your denominator is just growing. So who cares if it's 1 or negative 1? If you're dividing by 1,000,000, what are you approaching? Whether it's 1 divided by 1,000,000 or negative 1 divided by 1,000,000, you're essentially 0. I'll remind you that this graph does this. It kind of comes up here, there's a hole at 0, and then it oscillates back and forth, but then kind of squeezes the x-axis. Remember that? Same thing on the negative side. It comes down, oscillates back and forth, and then squeezes along the x-axis. How about this one? We should know our end behavior for a positive x cubed graph, right? Positive x cubed, it's x cubed polynomial, so it's opposite end behavior. It's positive, so overall it has a positive slope. So what is our limit as x approaches infinity? Infinity. That would technically qualify it as big over small, wouldn't it? Because it's technically over 1, so a degree of 3 over a degree of 1. So it technically qualifies as this big over small. and then we have an answer of infinity or negative infinity. Okay? And as x approaches negative infinity, same graph. Elise, what do you think? Yeah. Okay? And then, again here we have big over small. So if I'm plugging in an infinity number, right? Big over small, your answer is either infinity or negative infinity. If I'm plugging in an infinity number, so 1,000 or 1,000,000, is the numerator going to be positive or negative? Positive. What's your denominator going to be? Positive. And so overall this is positive infinity. As you approach negative infinity, what's your numerator going to be? Let's pretend I'm plugging in negative 1,000. What's your numerator going to be? Positive. What's your denominator going to be? Negative. So I'll show you that graph. 2x squared minus 4x. Okay, so as x is approaching, so as x is approaching infinity, this is approaching infinity like we said, yes? Tell me why I'm not seeing what's happening as x approaches negative infinity. Yes, Jenna, there's an asymptote at negative 1. Look at your denominator. You have an asymptote at negative 1, and whatever's happening is occurring off my screen. So if I look further down on my y-axis, like negative 50, there's the rest of it. So as we approach negative infinity, like we thought, this is going towards negative infinity. Look at here again. There is a diagonal line that is an asymptote. We can get the equation for that diagonal line by doing long division. Oh yeah. Fine, I won't do the long division. I just kind of wanted to do it again to see about your philosophy. I'm not going to. But Owen had a curious question. This is how you find out the answer. You do more examples.
After yesterday, I'm not saying.
I will do it and let you know.